Bismillahirrahmanirrahim. Assalamu alaikum. Kindly like, share and subscribe La Educator. Today our topic of physics are elasticity, stress, strain, Hooke's law and Young's modulus. We know that length of a rubber band increases on stretching it. Similarly, the pointer of a spring balance is lowered when a body is suspended from it. It is because the length of the spring inside the balance increases depending upon the weight of the suspended body. If you look at these pictures, you can see that there is change in these objects due to the force acting on them. The applied force changes the shape, length, volume of a substance. That applied force that changes the shape, length, or volume of a substance is called deforming force. The property of a body to restore its original size and shape as the deforming force ceases to act is called elasticity. It means that when the deforming force, which changes the shape, size, or volume of an object, stops acting on any object, then the body restores its original size or shape. That is called elasticity. As you can see in this picture, this straw which is bent, when we stop applying the force or deforming force ceases to act, it comes to its original shape. Just like this rubber band. Stress. Stress is related to the force producing deformation. The force acting on unit area at the surface of a body is called stress. So on the surface of any body, the force acting on the unit area of that body is called stress. Formula of stress is equal to force per unit area. SI unit of stress is Newton per square meter. As the unit of force is Newton and the unit of area is square meter. So the unit of stress is Newton per square meter. Strain. When stress acts on a body, it may changes its length, volume or shape. A ratio of such a change caused by the stress with the original length, volume or shape is called as strain. So basically the strain is a ratio between a change caused by the stress with the original shape, length or volume. So if the stress produces a change in the length of an object, then the strain is called tensile strain. The strain which changes the length of an object is called tensile strain. As a unit of strain is no unit because it has no unit because it is simply a ratio between two similar quantities. So as a unit of stress is Newton per meter square, and there is no unit of strain because it is simply a ratio. Hooke's law. The strain produced in a body by the stress applied to it is directly proportional to the stress within the elastic limit of the body. The strain produced in a body by the stress. When we apply stress on a body, it produces strain. So the strain produced by the applied stress is directly proportional to the stress within the elastic limit of the body. If we see mathematically, stress is directly proportional to strain. We will change proportional with the sign of equality and we put a constant. So stress is equal to constant into strain. And this constant is equal to stress divided by strain. Hooke's law is basically applicable to all kinds of deformation and all types of matters that are solids, liquid or gases within a certain limit. This limit tells the maximum stress that can be safely applied on a body without causing permanent deformation in its length, volume or shape. In other words, we can say it is a limit within which a body recovers its original length, volume or shape after the deforming force is removed. When a stress crosses this limit, means elastic limit, when the stress crosses elastic limit, a body is permanently deformed and is unable to restore its original state after the stress is removed. So the elastic limit, when a stress crosses this limit, body is permanently deformed and it is totally changed. We cannot restore its original state. Young's modulus. Now consider a long bar of length L0. We have a bar whose length is L0 and cross-sectional area A. Length of the bar is L0 and its cross-sectional area is capital A. Let an external force F equal to the weight W stretches it such that the stretched length becomes L. So the original length was L0. A force F equal to its weight is applied on it and it stretches that bar to length L. According to Hooke's law, the ratio of this stress to tensile strain is constant within the elastic limit of the body. So the Young modulus is the ratio of stress to tensile strain. Young modulus is ratio of stress to tensile strain. If we see mathematically, here we can see Young modulus is represented by Y is equal to stress divided by tensile strain. Now delta L will be the change in length of the rod. Delta L is change in length which is equal to L minus L naught. L is increased length and L naught is original length. So when we minus original length from increased length, we will get delta L. That is change in length of the rod. As we already know that stress is equal to force per area. That is F divided by A. And tensile strain is change in length divided by original length. Change in length is represented by L minus L naught from here and original length is L naught. We can also write it like delta L, that is change in length, divided by original length is that is L naught. As the formula of Young modulus is stress divided by tensile strain. So the formula would be F divided by A multiply L naught divided by delta. The formula of Young modulus is Y is equal to stress divided by tensile strain. Stress is represented by F divided by A and tensile strain is represented by delta L divided by L naught. As you can see these two values, when we arrange them, then F is equal to A and as delta L over L naught is in denominator, when it comes here, it L naught becomes numerator and delta L become denominator. F over A multiply L naught divided by delta L. So Young modulus is equal to F L naught divided by A delta L. So basically it is the formula of Young modulus, which means that formula is Young modulus is equal to F L naught divided by A delta L. It is the ratio of stress to tensile strain. SI unit of Young modulus is Newton per square meter. Thank you.